The universe is often described as a place filled with light. Stars illuminate galaxies. Galaxies fill the darkness with billions of suns. Across unimaginable distances, light travels through space carrying the story of cosmic history. Yet what if much of that light is missing? What if countless stars that should exist can no longer be seen? This question emerged from one of humanity's greatest scientific achievements, the James Webb Space Telescope. Positioned nearly a million miles from Earth, Webb was designed to peer deeper into the cosmos than any telescope before it. Its mission was simple in concept but extraordinary in execution. Look farther. Look earlier. Look closer to the beginning. Every image captured by Webb is effectively a glimpse into the past. Because light takes time to travel, observing distant galaxies means seeing them as they existed billions of years ago. The farther Webb looks, the further back in time humanity can see. Scientists expected to discover ancient galaxies, primitive stars, and clues about the birth of the cosmos. Instead, they found surprises. Some galaxies appeared larger than expected. Others seemed more mature than current models predicted. And hidden within the growing mountain of data was an even stranger possibility. The universe appeared dimmer than it should be. Calculations based on existing models suggested that enormous numbers of stars should be contributing light to the observable universe. Yet observations revealed a discrepancy. Something wasn't adding up. The expected brightness of the cosmos and the measured brightness did not perfectly match. At first, researchers suspected observational limitations. Perhaps thick clouds of cosmic dust were blocking the light. Dust is common throughout the universe. It absorbs radiation and hides stars from view. But Webb was specifically designed to see through much of that dust. Its infrared instruments could detect wavelengths invisible to previous telescopes. The mystery remained. Another possibility involved black holes. Some scientists proposed that large populations of massive stars may have collapsed directly into black holes without producing the brilliant explosions known as supernovas. If true, entire generations of stars could effectively disappear from the visible record. Instead of ending in spectacular flashes of light, they would simply vanish into darkness. Yet even this explanation struggled to account for the scale of the discrepancy. The numbers were enormous, potentially involving hundreds of billions or even trillions of stars across cosmic history. As researchers investigated further, a deeper realization began to emerge. The mystery might not be about missing stars at all. It might be about missing visibility. The universe itself could be hiding its contents from us. Every second, space expands. Galaxies drift farther apart. Light traveling across the cosmos must cross an ever-growing ocean of expanding space. As it does, something remarkable happens. Its wavelength stretches. Astronomers call this phenomenon redshift. The farther light travels, the more it is stretched toward longer wavelengths. Eventually, that light becomes so diluted and weakened that detecting it becomes extraordinarily difficult. In a sense, the universe slowly erases its own history. Ancient light fades into the background. Distant structures become harder to observe. Information slips beyond reach. The missing stars may still exist. Their light may still be traveling. But by the time it reaches us, the signal could be so stretched that it becomes nearly invisible. If that is true, then humanity faces a profound limitation. No matter how powerful future telescopes become, some parts of cosmic history may always remain hidden. Not because they no longer exist, but because the universe itself is carrying them beyond observation. And according to some astronomers, this may be only the beginning of an even larger mystery. The deeper scientists look into space, the more they realize that visibility is temporary. Everything we observe exists within a cosmic horizon. Beyond that horizon lies a region forever inaccessible. A realm from which light can never reach us. This is one of the strangest consequences of an expanding universe. Most people imagine space as a vast empty stage where galaxies move around like actors. Reality is far stranger. Space itself expands. Every moment, the fabric of the universe stretches. Galaxies are not simply moving through space. Space is growing between them. This discovery transformed modern cosmology. But an even greater surprise arrived decades later. The expansion was accelerating. Instead of slowing down under gravity, the universe was speeding up. Something unseen appeared to be pushing the cosmos apart. Scientists named this phenomenon dark energy. Today, dark energy remains one of the greatest mysteries in physics. No one knows exactly what it is. Yet its influence dominates the universe. As expansion accelerates, distant galaxies gradually disappear from view. Not because they are destroyed. Not because they stop existing. But because they cross the boundary of observability. Their light can no longer overcome the expansion of space. Eventually, entire galaxies become unreachable. Then galaxy clusters. Then vast regions of the cosmos. Future civilizations may live in a universe that appears almost empty. They might never know that billions of galaxies once filled the sky. Evidence of the larger cosmos could vanish entirely. Against this backdrop, the mystery of the missing stars takes on a different meaning. Perhaps the universe is not simply losing stars. Perhaps it is losing information. Every year, light from distant objects becomes slightly more stretched. Slightly more diluted. Slightly harder to detect. The cosmos is slowly pulling a curtain across its own past. Yet the James Webb Space Telescope continues to push against that curtain. Each observation reveals structures that challenge existing theories. Some galaxies appear surprisingly massive for their age. Others seem to have formed stars at astonishing rates. The early universe may have been far more active and complex than scientists once believed. If current models require revision, the consequences could reshape our understanding of cosmic evolution. New theories may emerge. New physics may be required. And entirely new questions may appear. That has always been the pattern of scientific discovery. Every answer uncovers deeper mysteries. The James Webb Space Telescope was built to study the origins of the universe. Instead, it has revealed how much remains unknown. The missing stars may eventually be explained by dust, black holes, redshift, or some combination of known processes. Or they may point towards something entirely unexpected. A hidden chapter in cosmic history waiting to be uncovered. For now, astronomers continue searching. Analyzing photons that began their journey billions of years ago. Piecing together fragments of an ancient story written across the sky. And with every new observation, one truth becomes clearer. The universe is far larger, stranger, and more mysterious than humanity ever imagined. The deeper we look into the darkness, the more we discover that the darkness is not empty at all. It is filled with questions still waiting for answers.